I am from Erie, Pennsylvania. I am not a professional woodturner. I'll repeat, I am not a professional woodturner. So if you've had Stuart Batty or Nick Agar or Johannes Michelson come in, they always talk about how they were an apprentice and how they grew up and learned. I've only been turning for about 5 years, but I want to give a little bit of background. I have been doing some woodworking, so I'm going to talk to this, but I wanted to give a little background on myself. So again, I'm not a professional woodturner. I want to calibrate your expectations. But I've been woodworking for 45 years, starting in high school. I'm the president of Presque Isle Woodturners in Erie, PA. We have about 75 members, so we're a growing club. I'm taking great notes about your wonderful setup here and all the things you're doing to kind of share best practices. I attended Penn State University. Sorry, I know I'm in rival country here. If you go to throw tomatoes, wait till I'm behind the glass. Okay. I went to Penn State. I have a Bachelor of Science degree in Industrial Engineering, a Master's in Manufacturing Engineering. That was my career, okay? I worked at a company called Lord Corporation. It has since been acquired by Parker Hannifin. There's probably people familiar with Parker Hannifin in this area. And I worked there for 35 years, and I retired a year ago. I stayed after the acquisition. I stayed and worked the transition for 3.5 years, and now I'm retired. I have 3 children, 2 grandchildren. My children all have done woodworking and turning. Again, I've recently retired. I want to give you a little bit of my motivation. I love working with kids. I love teaching the skills and the trade that I was blessed, truly blessed to have learned. And I had 2 mentors. One was my father, who built our house and had lots of talent in woodworking and construction. And then my industrial arts teacher, who was truly incredible. I'm very happy to talk about Presque Isle Woodturners is sponsoring and supporting a Northwest PA Regional Youth Turning Seminar this year. One of our members is a shop teacher at a local high school. He was also a graduate from my high school and had the same teacher I did and the same spirit. He wrote an AAW grant, got $1,500 to put on a youth turning program at the high school. We have 4 different high schools involved. It will be during school, an all-day long class. We have 2 instructors coming in, plus 5 different volunteers that are going to oversee them, and they're going to make a bowl with an embellished perimeter around the top rim. So they're going to learn, actually they know turning already, but they're going to turn the bowl and then do some wood burning and coloring, and we're very excited about that, and we're looking to carry that on. Next slide, please. So today, we are going to make this captive ring baby rattle. Okay, that's the demonstration we'll do. I'll pass this around. If we could go to the next slide, please. So it starts with design, and actually I saw running before the meeting, there was a slide about design requirements for rattles. And so I went to the Code of Federal Regulations before I made this, or before I designed it. And in Title 16, Chapter 2, Subchapter C, Part 1510, there is actually a regulation on requirements for rattles. And I'm upset with myself because so far the only thing I've forgotten to bring was the actual gauge. I made a gauge that is this size. And that gauge, it's basically an inch and 3/8 in diameter, and this is not quite 2 inches. And it is intended to represent the mouth and breathing cavity of an infant. And obviously you would not ever want to have something be lodged in an infant where it could impede their breathing. And so that gauge is intended to, you may not be able to fit any element of a rattle or toy for an infant through that gauge, okay? It's pretty straightforward, but I wanted to bring it. That's an inch and 3/8. I'm pretty conservative. I wanted to go bigger to make sure that it wasn't even close. We're gonna make these rattles today at 2 inches. Okay, and that's roughly, this is about 2 inches, this ball. So is this one. So that is the design requirement. okay? So if you've seen some that look like a maraca, like a bigger headed rattle with a handle, actually those would violate this because the handle could fit through that cavity, okay? Now they're fine for a 5-year-old if he's playing an instrument, but for an infant, 1, 2, 3 years old, that would not meet the requirements of the federal regulations. Okay, next slide, please. So here's photos of the 2 different rattles. We'll go to the next slide. And so this is what we're going to walk through today. So we talked about the design of the rattle. You want the spheres, if you will, to be no smaller than 1 3/8 inches. I go bigger just to, again, be on the conservative side. And I'll talk about how I lay it out. I've got a rattle here with 4 rings. I've got a rattle with 3 rings. You could make 1. You just, if you wanted it smaller, that would limit the number of rings you could get in between the 2 balls, 2 spheres, okay? So we're gonna mount the material, we're gonna rough it to size, and then there's two main parts of this project, and one is turning spheres. And so I'm gonna talk about how you turn a sphere without a jig, how we can mathematically lay out and turn a sphere. I like the 2 pieces to match on the ends, so I lay them out carefully and turn the spheres. Then we will rough the rings to size, and then we'll turn captive rings. Those are the 2 main parts of the project, turning the spheres, then turning the captive rings. And then there's nuances on how to sand and finish, because once you, as it's going around, once you cut those off, they don't behave real well on the lathes. You need to manage those, and I'll talk about different ways to do that. So the piece going around, the one with is cherry, and that's what I'm going to turn today. I've got these mounted between centers. I use step centers, spring-loaded step centers, just as a safety precaution. This step center, this pinpoint here, I don't know if you can see that, the center on here is spring-loaded, okay? So as if I poke it in, it's spring-loaded, so it moves in and out. This moves in and out. Now, this one is a solid drive, so it's running from the drive head. This one has bearings in it, so it's spinning. So I use the 2 step centers, and the main reason is for safety. If I take too big of a cut and it wants to grab, this spring-loaded will allow it to slip. So the wood just slips on itself rather than becoming dislodged, okay? So these are number 2 taper, number 2 Morse taper. You can get these at Woodturner's catalog. I'm guessing Sorby sells them, but I like these to start, okay? So I'm gonna remount this. Okay, I've got my tool rest positioned slightly below center. I'm rotating my piece to make sure I don't have any obstruction between that and the tool rest, and I'm going to go to a roughing gouge. I don't know if we can see that. Just a standard roughing gouge, and I'm basically going to turn this round to start. It's a spindle, so not a bowl, so I can get the starting speed up pretty good. I'm anchoring the tool on the tool rest, so the ABCs of turning: anchor, ride the bevel, and then cut. I'm trying to anchor on my hip with my right arm, and I'm just moving my legs to rough it. This piece started out at 2 1/4, so I'm gonna rough it down as close to 2 as I can. Okay, I still have some square spots on it. Okay, I have my calipers preset for 2 inches, so I'm going to do a little bit of background work on cutting spheres. Okay, so this method of cutting spheres is called the octagon method. Okay, I'm going to stand to the right of it here, and I'm sorry to those that may be trying to chase me. So if you draw an octagon around the perimeter of a sphere, you've got 8 sides, okay? By definition, an octagon, it's 8 sides, every side is identical, okay? The width of the bottom is the same as the width of this side, is the same as the width of this side. And the octagon is always on the outside of the perimeter of the circle you're trying to turn. Does that make sense? So the round part is always inside the octagon. Next slide, please. So, mathematically, no matter what size sphere you're turning, the size of one leg of an octagon is always 0.14 times its diameter. Okay? So if you're saying, oh my gosh, he's going to get into math here, there's one simple formula, basically, 0.414 times the diameter. So you can make a sphere this big or a sphere this big. This leg of the octagon is 0.14 times the diameter. Next slide. The distance from the end corner, from this corner to here, is 0.293 times the diameter. That's always the same. The only variable is the diameter. Next slide. And so if you look, here is the hexagon or the octagon, and here is my sphere. The inner leg is 0.14 times the diameter. The outer side is 0.293 times the diameter. Okay? So I'm going to jump to here. So here is the sphere I want to turn on the end of the rattle. I want 2 inches. So 2 inches times 0.414 is 0.828. That's going to be the leg of every side of the octagon. And 0.586 is 0.293 times 2 is these 2 dimensions. And if you wanted to check me, if you add all 3 of these up, it comes out to exactly 2 inches. Okay? But the formula to remember, no matter what size sphere, 0.414 times the diameter. So for us, we're just going to remember this today because we're turning 2-inch spheres. Is everyone okay with that? Okay, next. Now, for those youngsters in the room that have geometry, this is Pythagorean's theorem, and I'll have one of you come up and explain how it works. I don't have any volunteers. You're going to have to trust me that the math works, okay? Those formulas work for every diameter, and I'm just not making it up. That's the Pythagorean theorem. There'll be a quiz at the end, but we're going to move on now. Next slide, please. So we're going to lay out our blank. Now, this is for a general sphere, not a double-ended, okay? So basically, if we made a 4-inch sphere, that's what my slides are oriented to, is a 4-inch sphere. Your blank layout would be 4 inches here and 4 inches in diameter. Okay, next slide. One of the steps we're going to do is, for a 4-inch sphere, one side of the octagon is 1.656. If you turn this diameter to 1.656, now you have that side of the octagon defined. Okay, one more slide. And so this is 1.656, this is 1.656, and so is this. Okay, so that's the next step we're going to do. Does that make sense? Everyone following? Again, I don't want you to get bogged down in the math.
When did we jump from 2 to 4?
It's a great question. I didn't modify my slides. I did a presentation at another site where it was a 4-inch sphere. I was just turning spheres, and so this is for that purpose. We're going to stay with 2, but I wanted to show when you turn this diameter here, that creates the sides of the sphere. Okay, but now we're going to stay with this math. Good question. Sorry about that. This is a bedan, B-E-D-A-N. I'm sure many are familiar with it. It's basically a double width parting tool. I like to use it because it's a little stiffer. So that's what I'm going to cut to size. I've got my calipers set exactly to 2 inches. And so I'm going to rough the ends where the sphere are down to 2 inches. Actually, I will take the opportunity to lay this out now. So I give a 1/2 inch at this end for clearance, for something to have my tailstock mount on. Then I'm going to put 2 inches for my sphere. Okay, this is kind of what I'm laying out. Okay, my cherry's a little bit bigger, but I've got 2 inches here for this sphere, a little bit for this leg. Then, because this isn't a pure sphere, it wraps down into the flat spot. So I leave another 3/4 of an inch in here to transition from the sphere into the handle. Then I'll mount from this end. But this end, I want to give a 1/4 inch for my tenon, then another 1/2 inch, and then my 2-inch sphere, and then my 3/4 for transition. That leaves all this material in here for my rings, the rings I'm going to turn. Okay? Is everyone following so far? So this from here to here, actually from here all the way down, is where I want it to be 2 inches. I'm going to go in reverse. So I'm going to rough this down to 2 inches in between, but I need to create a tenon, and my tenon is going to be heavier. So there's my tenon. I want to cut my 2 inches. Now I'm just going to finish roughing down to that 2 inches. Okay, so we'll recap a bit. Here's my tenon. I left this thicker so I have a shoulder to put it in up against my jaws. This whole length is 2 inches, roughly. This is all 2 inches. The 2 inches is the final shape of the sphere that I want, okay? So I've now cut this down to the point where this math applies, okay? Does that make sense to everyone? I'm going to now convert from between centers. I'm going to go to my chuck. So I'm just going to put my chuck on. Eventually, when I go to cut that off, I want to completely expose this end of the sphere, eventually, so I could sand that end and make it completely spherical. And so if I was still holding it with the stem center, I couldn't cut it off. So eventually, at the tail end, I will push that away and finish this off and just sand the back edge. Does that make sense? Okay. I've got it loosely in the chuck, and I'm going to put a little bit of tailstock pressure to seat it into the jaws and then tighten it. Okay, so I'm going to go back to laying out. So I had a 1/2 inch here. Let me find my... There's my sphere. Okay, now that's at 2 inches on both ends. Now I want to lay out my rings, okay? I'm just laying them out for visual purposes, but then we'll go back and we'll cut the sphere. So the rings, I'm going to put 3 on here. The main point is, and actually this is going to be a really long rattle. I could probably shorten it up some, but for the purpose of the demo, it's going to be a really long rattle. I'm going to put actually, I could go 4 rings. Rings are a 1/2 inch. So I've got them laid out. This is going to be material taken away, this material taken away, this taken away, this taken away. Okay, but for now, we're going to go to lay out our sphere. So the sphere is a 2-inch ball. I'm going to mark the 1-inch spot. That is the exact center of the sphere. And now I want to mark 8.28 inches. I want to create that part of the octagon. So I've got my digital mic set at 1/2 of that, 0.414 because the center of this is the center of the sphere, so I'm just going to mark 0.414 on either side of the center. So there, and there, there, and there. Now I will, sorry for the time it takes to mark it, but it's part of the process to lay it out to get it uniform. Still can't see it. So this is, I don't know if you can see overhead, this is the top of the sphere, the top leg of that octagon. And now to get the side leg of the octagon, I want to create this. Okay, the 8.28 down on the side. So now I am going to cut down to the side to a diameter of 0.8, what is it, 828. And I've got my calipers set. I'm going to triple check them. So these calipers are set to 0.828. So I'm going to turn this down and this side down to get to that diameter. So just to show you, this diameter here is the same as this mark on the top, okay? So that is a leg of our octagon, and the top leg is here. So now I'm going to go back and cut it one more time over here. Okay, now I've established the outer edges of the spheres. Now I want to establish the inner edges of the spheres, but again, the shape of this is not intended to be a sphere right down to a flat part of the handle, okay? It's kind of a smooth slope, okay? If you did that, it would look like a barbell, which might be a fine design, but I like to transition it smooth. So I don't go all the way to this diameter when I make these two cuts. And I'm visually leaving stock, okay? I'm just being conservative. I'm not going even close. So the next step is if we cut from this point on our shape down to that point. Just a 45-degree angle. We cut it off. That's starting the shape of the sphere, okay? And we just don't want to dip into here and cut the corner off the sphere. So I'm going to use a spindle gouge, and I'm going to cut from this line down to this line on a 45-degree angle. Okay? Same with over here. I'm cutting the ends off that octagon. Make sense? I'm just going to put a pencil line there so I could see it a little better. Now, also, there's probably members in the audience that could turn this sphere freehand and it would look perfect. I'm not that skilled yet. That's why I take the time to lay it out, because I want them to be same on each side. So I've cut that, and by the way, what I typically do is I get it close, and then I would go in with a skew and use it as a scraper, a wide skew, but the bidan, you just want this to be flat and not scoop. This side I'm going to have a little tougher time. I didn't leave myself a lot of room to get the bidan in. So I'm just riding the bevel. Now I do have a long bevel on that spindle gouge, but to help keep it flat, and I'm not going to be able to fully get in here. So we're close. Let me create some visual for you here. That's where the first bead's going to go. That's the second. The magic is only you need to create half-inch ring and then create space in between them. So these are not symmetrically laid out, but I'm just creating space to get in. So basically, on the other side, I've got to clear out some material. Go back to the bidan. Okay, that's basically clearance for me. I'm going to do the same on the other side. Now, I cut this side off of the octagon. I need to cut this side off, okay? But remember, I didn't take these two sections all the way down to the 0.86 because I want to leave room. So I'm not going to cut at a 45-degree angle. I'm going to get it there, kind of meet up where we're at, and then later work down the transition. Okay, we got our 45s. Now, doesn't look like a sphere yet. It is still boxy. It's an octagon. I just removed one of my lines. So, I'm going to go back, if we could, go to the PowerPoint for a second. So, here's where we're at. Again, imagine this was one end of it. I've got this side completed, that cut. So, it is an octagon at this point, one on each end. Okay? If we can go to the next slide, please. Now, we add an additional set of lines to turn it from an 8-sided object to a 16-sided object. Okay, so we're going to add additional lines. One more slide. So basically, if this is 0.828, if you cut that in half again and go to 0.414, that is where all these lines are established. Okay, so I'm going to go to that. I still have no, actually I moved them. Set these back up to, actually, forgive me. I cut 0.414 in half, and it should be 0.207. So I'm going to measure here. Now I'm splitting these in between. And now I could go down the sides. Now, you'll see in a minute, for a sphere this size, you don't need to divide more than this. But if you turn a sphere the size of a basketball, you need to keep subdividing to get closer and closer to a sphere. And I've got a picture when we finish up there. But I'm just going to put these lines on. Appreciate your patience. These lines give you the visual of where this 16-sided shape is, and then it becomes pretty intuitive of what your next steps are. So if you look here now, you could visually see I've got a sharp corner here, If I cut that off from one line to the next, I've taken it to now a 16-sided shape. And if I cut this line off, from one to the next. So I'm going to go back to the Bedan. So I've got my approximation. Now I could take this down a little more. To allow me to get in here. And at this point, the sharp points are rather subtle. So I use a skew as a scraper. To get the shape a little more refined. If you had the patience, you could turn it into a 32-sided object and keep cutting the corners and get very close. But this is really pretty close for the type of feature we're doing, as long as my size is close to where we're at. And again, we're going to come back and fix that transition. Okay. We're not perfect work yet. We're going to work on that shape. But for now, I'm going to go to the beads, okay? And I'm going to cut space in between the beads to give me room to work. Back to the Bedan. Now, I'm not going to a specific size yet. I'm just creating clearance. So now I'm going to go to spindle gouge, and basically I'm just going to rough these into shape, okay? So I'm just going to start with the tool open up here at the top, and just roll it to 90 degrees closed. So I can roll over half a bead, then roll over half a bead in the other direction. So I'm just going to rough these into shape to get off most of the heavy material. Okay, I've got those roughed into shape. Now we get into the captive ring turning. So this set, can you see from overhead? This set is from Sorby. I've got a beading tool, okay, which is not absolutely necessary because you can roll a bead. But the thing I like about this is it matches identically the captive ring contour, okay? So if I'm cutting the ring on the outside with the beading tool, it matches identically to the shape of the captive ring tool. So what I'm going to do next is I'm going to use the beading tool to shape these into a final shape. So this is a 1/2 inch beading tool, so it's going to create a 1/2 inch radius on this, and then the captive ring tool will come in and we'll create room for it, but it's going to come in and reach behind the ring, and with the tip of this, it will cut in behind the ring, and you work from both sides to cut it down to a very thin sliver that's supporting it, and then you'll cut it off, okay? So the first thing I'm going to do is just rough one out, or actually finish it with this. I just rotate it slightly. Now I'm rotating it around. I've got a full cut. I'm rotating it around. And if you see the shape of that, it gives you a much nicer shape than I did freehand. Okay, but it's a 1/2 inch diameter and it's got the full radius on it. When I go to cut these, my beads are a little wider, so I'm going to have to remove a little material, which is fine. So I'll go to those. I'm just revolving around that center point of the tool. Just kind of swaying my hips, revolving around it. Got to work to keep it engaged with the tool rest, make sure it stays flat. And then you can start sweeping around the corner to almost create a full bead, but just being very careful. It can be delicate. So it's a scraper. And I'm getting, I think I was, a little bit elevated on the back side of my handle, okay, treating it as a scraper. I'm not too exaggerated, but it's up a little bit, and it is scraping. And this tool, it'd be difficult to see here. If you could look at this angle, this tool has a taper to it. So it only cuts with the top edge of the scraper, just as if you had a regular scraper. So I sharpen mine with one of the credit card stones. I think I have it here. So this is a CBN. This is a 220 CBN on this side, 180 on this side. And I will take it. I'll just hold it here. I will I do it the other way. I stone backwards on the top side. Now, there's others in the room that may say that's not the preferred method. What I find is I get a good cut. I'm just trying to roll a burr, into that radius. I don't have the technique to go in and grind the radius, so I never touch the radius. I just stay on the top edge, roll a burr, and that way it keeps the integrity of the half-inch cut in good shape. But that's how I sharpen this, and I have found it to be effective. But I don't go inside the radius. And there may be others that have a different technique, but that's how I stone these. So these are cut. If you can see, I've got a little bit of fuzz down here where the bead was a little wider. So now I'm gonna kind of trim that off. I'm just gonna go to the side. Now I'm creating a little bit more space in here, because the captive ring tool needs more space to get in as you swoop in behind it. Now I'm going to use the spindle gouge to just cut away a little bit inside. Just so the captive ring tool doesn't have to do all the work. Okay, so now we will go to the captive ring tool. The way this is designed, it's a stainless steel cutter. Okay, it has the hook on it. The hook is screwed into the blade of the tool. Okay, and so this screw does not allow this to sit flat. You can't really rest the blade, so to speak, on the tool rest. So you need to create room from the tool rest. So I take this and I slide it out, and I make sure that I can get this in here so that I'm not ever riding on the screw. I've got room from the tool rest, but I don't want it so far. I don't want it out here to where this thing really rattles. Okay, so you kind of try to find a happy medium. More than once I've got it in there and the screw impedes my ability to move it, and then it's like difficult to get it out without breaking a ring. So I think this looks to be the right amount of room, or good enough. And so I'm going to start to walk in, and basically I am cutting with the top tip of that only. Okay, and it's basically shaving. Okay, it's a scraper. It's shaving, and when I get in there, I will even start to rock it or rotate it a little bit to find the sweet spot where it'll cut and where it'll throw nice shavings if it's sharp and if it's behaving itself. Then I'll flip to the other side, and you have to flip the tool over. Okay? And honestly, this could be delicate. I will admit that I've broken more than one ring. Okay? The one thing that it's easy to do is get this ring in behind and say, well, I'm just going to pull my tool out. and pull it out, and you just snap the ring off because you didn't reverse it out, okay? And I am just a tad high. You also have to watch the back end of this, that you don't undercut too far, that you start shaving off the front edge of your ring on the outside. And I could go down more, and it will be helpful to get more clearance. But I don't want to get the handle too thin at this point where it starts to get vibration or wobbly. It can sing a little bit. You've got that hook out there. It can sing and dance, but kind of see the rings that it pulls. You can see I caught a little bit of the outside edge. You can come back in with the beading tool. Clean that up a little bit. Starting to burn a little bit. Okay, so I've got them, I'll say roughed. There's probably a 1/16 of an inch web holding the rings onto the piece. This is where I would go and sand the rings, okay? And I won't do a lot of sanding in here, but this is where I would sand the rings to get the outside and as much around the corner as I can. But I've also done enough of these that when I cut these off, unsanded, I'm pragmatic that I want to find a way to ultimately turn the piece into something good. So I'm going to talk a little bit about these two pieces that I'll pass around, and then I'll use them. So first is when I cut these off, so these are free. They're cut off. And they're not sanded badly. But what I want to do is get a nice finish on them. So I will take 3 inches of paper towels. And I know it's not a good practice to ever use a cloth or a towel or something around spinning material because it could get caught, your fingers could get caught in it. But I use 3 inches of paper towel that have no tensile strength, okay? If something would get caught, they're just gonna rip. And so I wrap them. This is just a pad, pad of paper towels wrapped, and I tape off the 2 ends so that these just slide up and fit on there enough that I could mount this back up on the lathe and sand those to finish size. And it'll hold on there. If it gets a little loose, I add another ply of paper towel. Okay? So I'll pass those around. That's for sanding the outside. Now the inside, and actually I'll show this. The inside, these are all cut off, but there is that little rim, okay, that little web in there that needs sanded off. So what I do, and the more rings you get on, the little more crowded it gets, but I put a piece of sandpaper with like a non-slip grip on the backside, and I wrap it tight, and I tape it in place. And so then put this back in the lathe, and these things will spin like hula hoops. If they're really dancing, I'll take 3 of them and I'll tape them back, and then slowly turning, maybe 300 RPM, I can sand the inside of this. I can even rotate it on here to create kind of a radius, okay? And I will do that, but I'm gonna cut these off first. But I'll pass these around. That's how I sand the inside of the rings. I know someone else that will take a small Dremel tool and they kind of wedge it in there. To me, it's pretty tight. And this works pretty well for me, and I've got one other technique I'll show, but I'll pass this around. This is for sanding the ID, that's for sanding the OD. So I'm gonna cut one of these off, and I kind of sneak up on it, because if I had my druthers, I'd like to cut completely through that web so there's less to sand. But sometimes it just cuts loose. I haven't broken one yet, so that's a good thing. It's a good demo so far that I haven't broken one. Okay, I'm going to cut the one on the right off, and I'm going to sneak up on it. You probably can't see my hands. I'm rocking it a little bit until I get the sweet spot of where it's shaving best. Starting to burn a little bit. See it move? So it's probably difficult for you to see, but there is a little web in there that's, I don't know, probably a 32nd of an inch wide. Some chips are out of it, but it has broken free. And once you're in this position, you've got a safe ring, okay? That's goodness. I'm going to do one more, and then I'll show you how we sand, just to watch time. I wear hearing protection at home with this squealing, so sorry for the singing. Okay, so they're all free, they're all in one piece, and now is where I reduce the size of the handle so I can get in and work on that web, and I can get in and put the rest of the sandpaper on. So I'm just gonna do that. I don't like to get the handle thinner than a ½ inch, just preference, but I'll take it down until these rotate freely. This last one has its web is kind of lodged in there. There we go. A little more. Okay. I'm probably still a little heavy on the shaft. I know I am. But what I'm going to do now is just basically, I'll show you how to sand with the other pieces, but I want to just take this and finish my sphere joining into the center. So this, I use a spindle gouge, and I'm just working slowly down to get a good blend radius, and then I start to stand back and look, okay, how are my spheres? How do they look? Are they relatively the same size? Now I capture the rings. And I've never found them to hurt anything dancing around, but I'm going to work over here, and I just want to keep them out of my way. By the way, remembering that point was the definition of the 2 inches. Okay, so it's not a perfect sphere. I'm gonna feather it out. And while I'm at it, I'm going to work a little bit on the shape of this. You'll be surprised you can actually do some decent shaping with 100 grit sandpaper. Just moving to the other side. Okay, now here's where I would go back, kind of pick the final size of the center. You can see on this side I was transitioning a little more. I think this is probably 5/8. So if I pick that, I would just go back and smooth that. I'm going to go with the internal sanding. Okay. I'm going to remove the tool rest. And for these, I'll show you how they dance around. I may tape them up, but I take one at a time, slow it way down. And I can get the web out of there. And then I rotate it side to side. It helps get the rounded contour sanded. Okay, then I will tape them back for this. So then I take Now this is cloth-backed sandpaper, so if you don't use cloth-back, it will tear and rip pretty easily. But then if I want to get like down to 180, 220, I'll take a piece of this, put it in, and the grit, the adhesive, not the adhesive, the grit on the sandpaper here actually helps. And if I rotate it, I don't know if you can pick up the grain, but if I just slide this through, I can get a rotation where I don't have to continually rotate it. And so I can sand the inside of it. It takes 5 minutes a ring, but you can get a really nice contour on the inside. You can keep them rotating, and it helps keep the ring pretty round throughout the cross section. And again, if you don't use cloth back, it would have torn in half by now, just because I'm pulling on it fairly well. But that's the way I kind of do the finish sanding. Once I get done with 100, I'll go to 150 or 220 and just walk these through, and they come out pretty well. Any questions on the sanding of the insides? Okay, real quick, going to the outsides. Keep losing the chuck key. So for someone asked why do I keep using the Steb Center, it's so I can come back and sand if I have to and support them, but then eventually I'm going to pull the Steb Center away and trim off my nubbin, and then I can at least sand that part of the sphere. So these, I'll just get a light piece of sandpaper here. So again, the only thing holding these is the friction between the paper towels and the inside of the ring. And again, this is typically, if it's not a demo, I'm going to sand those to 180, 220 as a solid ring. Yes, I will just use this. And there's enough friction between the two that I could sand them. If I want to focus on one, I pull that out and I'll just focus on one, maybe working on getting on a little bit on the inside. But I found it to be a relatively safe way to do it and be able to sand the rings once they're cut off. Talk a little bit about finish. Because rattles often could be in the hands and mouths of infants, I choose something to be food safe. This one actually has a wipe-on poly, which this is not an active rattle, okay? But for ones that I either give as gifts or used, I use a mineral wax or mineral oil beeswax paste that is food safe, that could be applied and replenished. And I found them to be pretty effective. They get a decent gloss, and they're food safe and able to be used. There's one other, I passed this around. This is the other design. So this has 5 plies to it. So the outside in this case was Padauk. The inner layer was the next layer was Wenge, and then it was zebra wood, the inside, and then the same on the other side. And the way I make these is I will glue up one layer of the Padauk, Wenge, and zebra wood, and have that be one piece, and then a layer of Padauk and Wenge, a separate piece, and then I will cut basically drill a hole down in such that it doesn't come out the other side, but create a pocket, and then in each side, and then put the other piece back on and glue it in place. And so I just make sure that whatever I put in there, beads, or I've used dried peas. They don't make as much noise as I thought they might, but put them in there, and I just keep them glued such that the deeper pocket, everything sits in the bottom so they don't get tied up in the glue. And then once it's laminated, I go through this process on the lathe. Okay? What you have to be very careful with this design is lay out the center of that pocket very clearly, because if you get off a 1/4 inch, you can turn your way into the cavity. And that's what happened on this one. I didn't turn into it, but it got really thin, and so I did a patch. So, any questions about Rattles?
Do you have any concern about the exotic woods?
That's a great question, and I've never thought of it. I've never thought of that. But that's a really great question.
What's the answer?
I don't know yet. Believe me, I'm gonna look at that.
That federal regulation has a thing about testing.
Yes.
You have to test the design, or you have to test each piece, or?
It's essentially, it's a gauge, okay, and it's a elongated pocket. It's not an oval, but it's an elongated pocket, and theoretically, no portion of the rattle may fit through there to pass, okay? But the pocket's essentially 1 3/8 in height, and because I'm at 2 inches or 1 3/4 inches, there's no chance that it could fit through there. But I've seen other rattles commercially available. They might have a ball on the end, but like have a key design on the bottom. And if that key design were small enough, it could fit through there, and that would make it not recommended for children's use. I actually saw, as I was preparing this, I happened to be with my grandchild earlier this week, and he has it's essentially a base with a dowel, and then it was a clown turned in the shape kind of like a bowling pin, and then it was sectioned. And then the part of playing with it is you dump them off, and then you put it back together in the shape of the bowling pin. Well, there were 3 pieces that I guarantee would have fallen right through the gauge. And you wonder how that applies, but it definitely, as part of the rattle, it may not fit through that gauge. And because I design it with a big enough diameter, there's no way. That's just part of it. But if you were sculpting or putting a handle on it, or like I said, a maraca that might have a 1/2 inch handle, I would say, according to the federal regulations, they would say that's not recommended for an infant's rattle. It might be for a 5-year-old's musical toy, but not for an infant's rattle. They didn't make enough noise.
And what is good then?
BBs, or I've used nuts, threaded nuts, and they're heavy enough. And my first concern was, well, I wouldn't want anyone to choke on that, but they're encased in there. They're just heavy enough that they rattle around pretty well. I think that one has metallic nuts in it. BB's is a little lower pitch.
Yep.
But my recollection, it was 3/4 diameter, and I'm going to guess this head is about 1.5 or 1 3/4. I can check, but 3/4 in diameter, which I thought I wanted the cavity to be big enough that there was room for the nuts to move, so you could hear them. Where if it was just a little pocket, and they could barely move. But like this one, I was off lengthwise when I was turning it, and my wall got thin. And so I could have been conservative and made a smaller pocket, but probably wouldn't have got as much rattle. So my lesson from that is really mark where the center of those cavities are so that I can make sure that when I'm turning the wall, it is uniform. This, the other end, I will use a Japanese saw. And I'll cut that off close, and then I mount a sanding pad in my drill press, and then I'll polish it on there to get it, as round as possible. Good question. I forgot one thing, and this is very important to me. There is an audience participation part that I have to ask for. So if I could have everyone stand, you've been sitting for a long time. If everyone could stand, please. This is important. So I'd like you to think of a number between 1 and 10. Between 1 and 10. All odd numbers, I'd like you to do this. All even numbers, I'd like you to do this. Okay, now hold that pose. Hold that, please. Hold just a second, bear with me. Good. Excellent. Excellent. Okay. Now you're wondering what I'm doing. You could have a seat. My youngest son, who is a turner, he knows about Presque Isle, he knows about North Coast, but he's been away at school, and he wondered where I was going today. He was at home, and I told him I'm going to demonstrate at North Coast, and he said, well, that's a big club, and they have a bunch of professional turners that come in that are really good. He goes, you might be out of your league. And I said, well, I very well may. And he goes, Dad, you're way out of your league. And it got to me. And I said, you know what? I'll bet you a pizza that I can give the most inspiring, most passionate demonstration that I'll get a standing ovation. But he said I needed to provide proof. So thank you for bearing with me. I got my proof. And I will be eating pizza this evening. So thank you very much.